Okay, so in this class I want to look at proving trigonometric identities number 5 and 6. Really straightforward. Identity number 5 is this. It's a compound angle identity, and it says the cosine of the sum of two angles is equal to cosine of the first angle times cosine of the second. Subtract sine of the first times sine of the second. In order to know the proof, you need to know identity number 4, which we proved in our last video lesson. Cosine of A subtract B is equal to cosine of A cosine B plus sine of A sine B. And you need to know the cosine and sine of negative angles. So cosine of negative A is always going to be the same as cosine of A. Sine of negative A is always going to be the same as negative sine of A. And we've shown those in normal class, but if I just go through this very quickly, thinking visually, we've actually proven these using identities. But actually, if we just think about some positive angle A, what does that mean? If I'm looking at some positive angle, and it doesn't really matter where it is, let's just stick it in the first quadrant, keep things simple. If I call this angle in here A, I'm just on the unit circle here. We're talking about a positive angle has an anti-clockwise sweep. That direction, unit circle, the radius is equal to 1. This point up here would be x comma y. Cosine of A here, cosine is defined as being, of any angle is defined as being its x-coordinate divided by the modulus of the point. So in this case, cosine of A would equal to x coordinate divided by 1, which is just whatever the x-coordinate is. And it doesn't matter where I go, that's always going to be the same. If I just look at the equivalent negative angle, and actually if I just think about a vertical line down here, I'm just going to draw a vertical line straight down here, and I'm going to think about a negative sweep, which is a negative angle. That angle there, hopefully logically you can see that that angle in there would be the angle negative A. And its coordinates, well, it would have the same x coordinate, but it would have the opposite y coordinate. So cosine of that angle, negative A, would be negative x. Let's say would be also positive x, the same. So cosine of negative A and cosine of A are the same. If I think about sine, my sine ratio, the sine is defined in general as being y over or. In this case, on the unit circle, sine A is going to be the y coordinate. Up here, the y coordinate divided by 1, which is just y. And sine of negative A is going to be, well, the y coordinate down here is actually the negative of that. That's negative y, which is, of course, the negative of sine A. So these things should make sense. But you got to know them. They're on page 13 of your tables. So let's look at the proof. So I'm going to prove this identity. This is identity number 5. So I'm just going to start with cosine of A plus B. And I'm going to rewrite that as cosine of A subtract negative B. Because, subtracting a negative is the equivalent of adding a positive. So I just put a square bracket around there. So cosine of A subtract negative B. Now we have the difference between two angles. And we're going to use identity number 4. Identity number 4, remember, says cosine of A subtract some angle, the difference between angles. Well, it's cosine of the first angle times cosine of the second angle. In this case, second angle is negative B, plus sine of the first angle times sine of the second angle. In this case, that is negative B. Also, we've shown that cosine of negative B is the same as cosine of B, so that's just cosine of A times cosine of B, plus sine of A times, well, we've shown that sine of negative B is the negative of sine of B. That's one of my identities. And then one more step, and that means that cosine of A cosine of B, sorry, not plus, we've got a positive here times a negative, so that's giving me a subtraction, a negative sine A sine B. And that's identity number 5, that the cosine of A plus B is equal to cosine A cosine B, subtract sine A sine B. Okay, that's identity number 5. And we can use identity number 5 then to prove identity number 6. Identity number 6 says that cosine of 2a, this is a double angle formula, is equal to cosine squared A minus sine squared A. In order to prove that identity, we need to know identity 5. And this is really straightforward. So to prove this, I'm going to take this cosine of 2a and I'm going to rewrite it as cosine of the sum of two angles, A plus A. Okay. And using identity 5, well, that's cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. And that's equal to cosine squared A subtract sine squared A. And that is identity number 6, which says cosine of 2a is equal to all that stuff. Okay. And those are 2 of the 9 mandatory proofs in our course. You have to know them and know them by heart. Okay, so in order to prove identity number 5, there's a few bits of background of information you have to know. You have to know identity 4. You have to be able to find the cosine and sine of negative angles. In order to prove identity number 6, you need to know identity number 5. Okay, and they're proved kind of sequentially. You use previous identities to prove later identities. Okay, so get the hang of those. Make sure you know the identities, know where to find them, and these first 9 identities you must learn to prove.